Earlier grades, we have studied motion and its types. Let's have a quick review. Let's start with motion. In simple words, if a body is moving, it's described as motion. That's all. In slightly more technical words, motion is defined as a change in the position of a body with time. Yes, change in the position with time. For example, when an object is moving from point A to point B, it's changing its position with time. We saw that the time is also changing along with the position. So it is undergoing motion. What are the types of motion that we had studied previously? We have seen 4 types of motion. The simplest of all is the rectilinear motion. It is the motion of a body in a straight line. The example that we saw earlier is of a rectilinear motion. Object is moving in a straight line from A to B. There is another type of motion called a circular motion. What can this type of motion be? It is the motion of a body along the circumference of a circle. Example: motion of the Earth around the Sun is an example of circular motion. The third type of motion that we saw is a rotational motion. It is the motion of a body around a fixed axis which is passing through the object. This is important. The axis has to pass through the object. Example of rotational motion is a ceiling fan rotating along its axle. So you see that if I draw a hypothetical line called the axis of rotation, then it's passing through the fan. And the final type of motion is the periodic motion, which is the motion that repeats itself in equal intervals of time. Can you think of any example of this type of motion? Any object repeating its motion in equal intervals of time will be undergoing periodic motion. Assume an object is moving in circles and is covering each round every 3 seconds. Is it performing a periodic motion? Absolutely. Since it's repeating its motion along the same path every 3 seconds, it is undergoing periodic motion. But wait a moment. This object is moving along the circumference of a circle. So it is also undergoing circular motion. So what can you conclude from this example? We can say that an object can undergo more than one type of motion at the same time. Here are the few of the examples of motion in our everyday life. Go through them well and tell me what type of motion each one of them represents. And note that one example could also have more than one type of motion. The first one is clearly rectilinear motion. It's a car moving along a straight line. The second one is interesting. Most of us would have guessed rectilinear motion after seeing the word straight. Which type of motion are the wheels of an automobile performing? Are they undergoing rotational motion or rectilinear? When we move from one place to another, the measure of total length we cover is called the distance. So you have to travel to this town, and the best route is straight up north. But because of roadworks along the way, we have to take a detour, and the distance covered would be something like this. Now when the roadworks are completed, the distance needed to be covered will be something like this. Distance is measured in meters and denoted as lowercase m. The distance between these two towns is about 20,000 meters, but because of the detour, you had to cover a distance of 50,000 meters. Okay, so nobody likes big numbers unless it's your salary. So we should also know that a kilometer is 1,000 meters. In our example, we can say that instead of 20 kilometers, you traveled 50 kilometers. Is distance a scalar or a vector quantity? Think about it. If you say someone travels 20 kilometers from this point, we can't really tell where they landed up. Maybe here, maybe there, or maybe they just went around in circles. As it does not specify a direction, it is a scalar quantity. That brings us to displacement. So what is displacement? Distance with direction is displacement. Distance with direction? What do we mean by that? You made 2 separate trips to this town. Was the distance covered in both the cases the same? Have a good look. It wasn't. In each of the 2 cases, the distance was different. The time you took for the detour was greater than the time you could go straight across. But if you call someone to tell them where you are, in both the cases, your location is this town, which is 20 kilometers north of your home. The displacement in both the cases is the same. You traveled 20 kilometers north. North shows the direction, and because direction is specified, displacement becomes a vector quantity. Now let's look at this example where a mother asks her son to quietly stay where he is while she takes a quick nap. So now the child runs back and forth many times and returns to the original spot before the mom wakes up. The mom wakes up and sees the child in the same spot, and as she hasn't observed what happened in the last few minutes, she assumes the child has not moved. The child, being the future expert in physics, has in fact disobeyed her instruction and covered lots of distance. But at the same time, he can argue that he did follow his mom's instruction. Lots of distance covered, but zero displacement. If the distance traveled is a straight line, the displacement will be the same magnitude as the distance, but with the direction provided as well. In most cases in our day-to-day lives, the distance covered is greater than the displacement seen. Running errands and traveling back and forth between places cause the amount of distance to build up, though you may not end up very far from home. If you've really understood the difference between distance and displacement, you should be able to answer the next question. When a passenger travels by taxi, is he charged based on the distance or displacement? Taxis charge passengers based on distance. If you go to the neighboring town and return in the same taxi, the taxi meter shows you the charge for the entire round trip. If you now try to explain to the taxi driver that you have had no resultant change in your location and hence you must pay nothing, it will not impress him much.